The two big concepts that we have here, guys, is breathing, pulmonary ventilation, and gas exchange. What are the muscles, the pressures/forces involved? What are the anatomical structures that are involved in helping to regulate breathing? That is what pulmonary ventilation encompasses. Okay. After we breathe, then we'll look at how oxygen and CO2, those are the only two we're going to be worried about, how oxygen and CO2 get in from the air to the blood, how oxygen and CO2 get from the blood into tissues and tissues back into the blood, and how we exhale it all at the end. So we're going to look at transportation of these nutrients, of these gases. That's what we have left. They are intuitive. There's a lot of verbiage. I'm going to try to highlight specific things, and I pray to the gods that you are paying attention right now and you are highlighting along with me, because there are certain pieces that I'm not going to dive into and I'm not going to ask about on the exam. The stuff that I highlight or underline, star, whatever the case may be, that is generally the stuff that gets asked more on my exams or on any type of board exam to become a nurse. So let's look at breathing. Pulmonary ventilation. And as you can see, there's a number of, questions associated with this physiology here. But when it comes to pulmonary ventilation, it incorporates all of these aspects. Okay. The movement of gases from the atmosphere, the air, into the lungs. Okay. That is pulmonary ventilation. That is breathing. One of the major functions of the respiratory system, right? We have to have exchange of these gases in the lungs. So we're going to look at how oxygen jumps from the alveoli into the red blood cells, and how carbon dioxide gets from the blood into the alveoli and out into the environment. Then we're going to see how gas gets transported. Oxygen and carbon dioxide get transported. Hell, we already know this, right? We saw it within the blood. Oxygen and carbon dioxide get picked up by red blood cells. Well, now we're going to look at the mechanisms for how they load up. Okay. God, wouldn't it be so simple if it just said, okay, it just loads onto the red blood cell and CO2. There are a number of interesting things that occur on a red blood cell to make it want to hold oxygen or CO2 respectively. Okay. So we'll look at gas transport. Then we'll look at systemic gas exchange. It's more than just those two major forces involved with capillary exchange, right? Of course it is. There has to be. So systemic gas exchange is going to look at the exchange of these respiratory gases between the blood and the systemic cell. So we're going to look at the specific mechanisms involved for the unloading. It's all going to be based on pressure gradients. I'll just tell you right now. You're going to have a very high in one spot, very low in another spot, all right? It's basically diffusion, all right? But there's going to be numbers attributed to these things, and it's going to be the same in one and flip-flopped in another. So there's a lot of moving parts, but I'm going to try to connect these all together, all right? To make all these numbers very easily remembered and understood. So let's talk about breathing, man. When we talk about breathing, pulmonary ventilation, a fancy way to say it, we are looking at two parts of this process. And I know you know it. Inspiration and expiration. Inhalation and exhalation, however you want to say it. Bringing air in, getting the air out. If you're all just sitting there right now You are undergoing, excuse me, oh my gosh, normal breathing. Normal breathing is quiet breathing. This is also called eupnea. Okay, this is normal breathing. I'm going to put normal here. Okay, normal. Okay, you're sitting there right now. Air is moving in, air is moving out rhythmically. There you go. Okay. There are two major muscles involved with that, and we'll talk about this, I believe, on the next slide. There is also called forced breathing. Okay. When would you force breathe? Can anybody think of an example? Anybody get up and exercise this morning? Anybody? What did you guys do this morning?
Roll out of bed.
God!
Fought with my kids to get ready for school this morning.
There you go. See, forced breathing. You got all pissed off. That sounds vaguely familiar. Forced breathing is anything vigorous. So activity, exercise. Maybe you're scared, excited. All of these things can be forced breathing. Generally, we think of exercise as forced breathing. Okay? I get up and work out in the morning. That's the only thing that saves me from not destroying children half the time, I feel like. Okay. So forced breathing. When we talk about forced breathing, we're going to get a number of other different muscles involved in here. All right. And we'll talk about that, I believe, on the next slide. Who regulates all of this? The brainstem regulates all this. It's where we had our pneumotaxic and apneustic centers. Okay. So we're going to talk about some specific anatomy again that we talked about earlier. We looked at the nervous system. We're going to be talking about them here again. Okay. And these structures are going to help regulate the electrical output to cause these muscles to contract and then stop contracting and then contract and then stop contracting and then contract. It's fascinating. And the funny thing is, when it comes to breathing, we know the parts and pieces. We don't quite understand all of the mechanisms involved. We know many of them, but there are some mechanisms that we know what they're doing. We just don't know exactly how. So it's fascinating. And I believe the book even comes out and tells you that too. It's pretty interesting. We're going to have muscle involvement, skeletal muscles. Okay. And these are going to change volumes. All right. And the volume that we're talking about here is the volume of the thoracic cavity, i.e. the volume of the lungs. Okay. When volumes change, we get changes in pressure. And I think we talk about it in a couple slides from now. Okay. When volume changes, we get changes in pressure. Okay. These are going to be key things. All right. That's going to be a key thing that we'll talk about here. All right. It's this change in volume, which is a law that helps us to change pressures, that allows air to move in certain directions, we'll see. Okay. Air always goes down its concentration gradient, or in this case, down its pressure gradient. Air is always going to move from an area of high concentration to an area of low concentration. Okay. It's always going to do it. Sorry, I have a lot of irons in my fire. Apologize. All right. I had to respond to that. So air is always going to go from high to low. Makes sense, right? Makes sense. So these are some constants that and these are some things that we're going to be talking about throughout this process of breathing. So let's look at the major muscles involved with normal breathing, eupnea, eupneic breathing, however you want to say it, all right? The two major muscles associated with the process of breathing are the diaphragm and the external intercostals. This is inspiration. Exhalation is passive. Okay. Exhalation, normal eupnea, breathing. Exhalation just happens. It happens when the muscles relax. There are no muscles engagement with expiration under normal circumstances. Okay. Under normal circumstances. The diaphragm, when you breathe in, diaphragm flattens out. Okay. If I take this breath in, here it is. As soon as that diaphragm starts to lower, what else is moving? My chest. Okay. My ribs. Okay. All of these guys are moving here. Okay. Just sit there and breathe. Okay. Yep. Okay. Now, I'm not going to over exaggerate here. I'm just going to breathe normally here. Okay, it's those external intercostals. Those external intercostals are contracting and elevating those ribs, pulling those ribs up and out. This helps to, as we'll see here in a second, we'll talk about it in a second, this helps to increase the space within the thoracic cavity. So normal breathing only involves two muscles, the diaphragm and the external intercostals. Those two relax and you exhale. Okay, those two muscles just relax. It's when you force inhale, forced inhalation, forced exhalation is when we get a number of other muscles involved. When it comes to forced inspiration, I have those listed here on the slide. Okay. And oh my God, you don't even need to see this. You can just cover those up. Okay. Just breathe. Okay. Everyone take a breath in. Now keep going. Keep going. Oh my God. Okay. Not relax. But what happened here? All this comes up, right? What is that? Just breathe again and just feel. Keep going. You feel all these muscles right here engage. The only really place that I get a change in volume when it comes to the thoracic cavity is up top, okay? Right up in this area here, all right? I mean, down here, they're already splayed out. So, I mean, they're going to be easily splayed out. Where's pretty much everything else happening? Up top, the sternocleidomastoid, your scalene muscles. You have an anterior, middle, and a posterior scalene. Your pectoralis minor. All of those things attach into the clavicle or into the first few ribs. And that's where we get the greatest change in volume. Okay. The serratus posterior, superior is involved with it as well. It's on the back side. It's not as obvious, but it's just right. It's just right here, deep right here. Okay, is where you'll find that muscle. That's why if you pull that muscle up top there, it's really difficult to forcibly breathe in or to exercise. We also have what's called the erector spinae muscles. And the erector spinae muscles, they just run kind of perpendicular here along the thoracic, along with the vertebra there, the vertebral column. These help to flatten out the spine, okay? When I flatten out the spine, okay, when I flatten out that spine, it helps me to create a little bit more volume. So we think of muscles involved with forced inspiration as all up front here, SCM, scalenes, pec minor, but there are a number of other ones as well, okay? And that's all I'm trying to impress upon you here. Okay, so take a breath in. Now breathe out. Breathe out. Breathe out. Keep breathing. Keep breathing. What do you feel engaged? Hopefully you feel all those abdominal muscles engage. When it comes to forced exhalation, it's your rectus abdominis, your transversus abdominis, your transversus thoracis, the external oblique. All of those abdominal muscles engage. Your lungs are in your thoracic cavity. What the hell is an abdominal muscle going to do? The abdominal muscles are down here, right? My lungs are up here. How is this going to do anything down here? How is this going to do anything down here affecting this up here? My thoracic volume.
Well, it's affected by the diaphragm moving.
Diaphragm is moving, sure. But again, I mean, the diaphragm's right here. Okay, it's right there. All my abdominal muscles. Here's my transversus abdominis. Here's my external oblique. Okay, they are down here in my abdomen. Why would these guys have any effect on changing the thoracic cavity volume? What is all this stuff? What is all this crap?
Looks like liver. Is that organs?
Yeah! Can't you tell the liver and the kidney and the spleen? Here's the stomach. Here's my jig-joggy mess of small intestines. Here's my large intestine. And boom. So all of these intestines, if you keep, okay, breathe in again. Now breathe out. Keep breathing. Keep breathing. Keep breathing. All these muscles are engaging. What are they pushing on? The organs. So where are the organs going to go? They got nowhere to go, right? They kind of get squished together and then they get forced up against that diaphragm. And what does that help to shrink even more? The thoracic volume. And that forces even more air out of those lungs. It's just like a sponge, right? If I was holding a sponge here and pushed it up, if the sponge was wet, the more I pushed it up and pushed up and pushed up and pushed up, more and more water would get squished out of the sponge. And that's basically what's happening here with forced expiration. Okay. Do I have forced expiration muscles listed on here? No. If I was to ask, name a few muscles associated with forced expiration, could you name the transversus abdominis, the rectus abdominis? I think you could. Okay. I think you could. Rectus abdominis will get involved if you get excessively hardcore at it. Okay. Internal intercostals, they pull the ribs down and in, pull the ribs down and in. They're the opposite of the external intercostal. Okay. So who are the two muscles involved with normal eupneic breathing? The diaphragm and the external intercostal. If it's forced breathing, if I said these are the muscles involved, or name the muscles involved with running across campus in terms of breathing, and then you're going to say, well, I mean, diaphragm and external intercostals will still be involved, but now we're going to get a bunch of aids. Okay, your SCM, your sternocleidomastoid, your scalenes, pectoralis minor. These are going to help inflate the lungs even more by increasing the volume of the thoracic cavity, by pulling those ribs up and out. As you are running for a longer period of time across campus because you had to go park in BFE, not only are you going to be forced inhaling, you're going to be forced exhaling as well. And that's when you get the transversus abdominis, the external oblique, the internal intercostals involved to help force more air out of the lungs so you can get more air in the lungs. That's how that works. I kind of talked about the respiratory epithelium. I don't know why they put this here later in this part here. Skip it. It's all about changing volumes. All of those muscles involved with force inhalation help to increase the volume of your thoracic cavity by pulling those ribs up and out, especially those first couple ribs. When you exhale, the thoracic cavity gets smaller and compressed, and that helps to force that air out of the lungs out into the atmosphere. Okay, so it's all about flattening out the diaphragm and expanding that thoracic cavity, that thoracic wall. Okay, pulling the rib up and out, all these fun things. All right, with exhalation, I make the cavity smaller. That increases the pressure within the lungs, and that helps to force the air out. Is everybody there with those two aspects? Breathing in, forced, increases thoracic cavity, increasing the volume. Exhalation compresses those ribs, compresses the thoracic cavity, and helps to force the air out of the lung. That is increasing the pressure within the cavity and ejecting the air. Everybody with me there? Perfect. Thank you. There are 3 basic laws that help us to govern and understand what we know about breathing. One of those is Boyle's law. Boyle's law is important because it helps us to understand breathing. As the volume of a space increases, the pressure decreases. And again, this is under a constant temperature. Okay. Which normally happens. Which normally happens. Okay. So if we look at this picture right here, okay, as you take the breath in, I'm increasing the volume of my space. I am also decreasing the pressure. All that is saying is that there's more space for these air molecules to bounce around. If I exhale, I am decreasing the thoracic volume. And now I am increasing the pressure, okay? There is less space within my lungs. There is less space inside that thoracic cavity, hence less space for my lungs. So now those air molecules come in contact with one another and can exert a higher pressure against one another. Whereas if I take a big breath in, the volume increases and now there's more space for everything to float around. So now these air molecules don't impose a pressure or a force on another air molecule. Ask your question.
Okay, well, it seems to me like it would be the opposite, but I think I'm thinking about like the tissue itself, like the lungs versus just the air or the gas. So like when you breathe in and the volume increases, it seems like the pressure against the lungs would be increased, but you're talking about the pressure in the air or in the...
We have two types of pressures, right? We got pressure within the thoracic cavity itself, and we have the pressure specifically within the lungs, all right? When I take that big breath in, when I take that breath in and then blow it out, it is that small little bit of extra pressure within the alveoli, within the lungs, that help it to prevent it from collapsing. It is the forces of the water interaction on the external surface of the lungs that allow it to rub up against the rib cage. And as you breathe up and expand those lungs, it hits it. And that serous fluid creates two watery structures together, and that helps to carry that out with it. And that'll help to expand those lungs. All right. So that's that pressure. All right. But think of it like this. If we have 100 people in a room this big, okay, you could easily space out. Okay. But if I take those same 100 people and put them in a smaller room, now they're going to be a lot more on top of each other. Okay. Do you see the difference? Because when air exerts a force, that force is a pressure.
Okay, thanks.
Okay. So more space means more volume, because there's a greater amount of volume in this cube than in this cube. And if I have more volume, I have more space. Whoops, sorry. I have more space. Okay. So the pressure that this air molecule can impose on another one is diminished. That's what that means. Okay. And it's this box right here. Okay. Melda, do you have a question?
No, I think I understand that now.
Okay. Okay, good. Because this is key. This is key. Okay. Volume and pressure are inversely related here. Okay. The more volume, the less pressure. Smaller amount of volume, the greater pressure. All right. This is basically understanding how air is getting from the outside to the inside, out in the atmosphere to into your lungs. Okay.
Sorry, sir. I don't know. Can we go back to the slide before this one? I think that's where the issue is. When we look at the slide where you have the vertical, where you have the expiration, this is expiration when you inhale, and then there is an expansion, the contraction of the diaphragm and the lungs, because when it contracts. And then when I look at below it there, during the contraction, we find out that the curve below, that is the diaphragm, is like depressed. It's also like an opposite thing here that is confusing. I was expecting that if this thing contracts, the diaphragm here too goes up, but I'm seeing the inverse on the other side when it exhales. when the expiration is there, when I'm expecting it to come down, it's going up. And the same thing on the next one below it, the lateral changes too. I was expecting these two to be the opposite, like number 3 should have been higher up, and then the opposite should have been lower. So this two now is actually what is not very clear to me.
Okay, so let's look at that. So this is looking down from above. Okay, here's my sternum, there's my vertebra in the back, and there's my rib going to it. All right. So as you breathe in, just put your arms around you. Okay, no one's there to see you. Okay, just put your arms around you right here. Okay, just take a breath in. Okay, no, don't feel it. I'm gonna scooch this down. There we go. Okay, now take a big breath in. See how that lateral changes? This is what they're looking at right here, the lateral.
Okay.
Okay, that's what they're looking at right there. All right, the lateral change. Now from here, now they're looking at it anterior to posterior. Okay, so those muscles involved with breathing, external intercostals, and the diaphragm drops down. When the diaphragm contracts and drops down here, that helps to increase the volume this way. As you take a breath in, those external intercostals engage and help to pull the ribs up and out. Okay, and in the lateral, the out part would be part of what they do. Now, if I look at it from front to back, let's do it again. I'm pulling that sternum up and out. This is increasing the volume this way, and this way. And you can only get volume in a three-dimensional thing, in a three-dimensional structure. That's where the volume comes in, right? So with those muscles, and now do it forced. Okay, now I get an even greater change. So this is just looking at it from a volume standpoint. Flattens it out, this increases. See this is increased, okay, compared to this. It does it lateral by getting those ribs to move out. And it also does it in the anterior to posterior plane by increasing. Now, I mean, it's not a whole hell of a lot. I mean, it's only a few millimeters, maybe an inch, but it's a difference in volume that you get there with that. Now, if I exhale, now the internal intercostals, they contract and they push those ribs in. Okay, you can see right through here, it compresses in. Those are the internal intercostals acting now. The transversus thoracis, the transversus abdominis, the transversus thoracis goes this way and helps to pull that rib cage in. Same thing down here with the transversus abdominis. Okay, it pulls across and brings that abdominal muscles in. External intercostals, they go out here to these ribs, go down here to the crest of the ilia, pull it down, pull it down. So we're doing all the opposite changes here with expiration. Decreasing the space, decreasing the space, decreasing the space. Are you with me now?
Yeah, thanks.
Okay. Boyle's law. All that it's related to Boyle's law. All those muscles engaging and not engaging there, all of them help to change the volume of the thoracic cavity, which helps us to change the pressure inside the lungs. Where's gas exchange occurring? In the alveoli. what is wrapped around those alveoli? Elastic tissues. Those alveoli can expand. And that expansion can only happen when I take a breath in, whether it's normal or forced inhalation. And that helps to diminish the volume of air in the lungs. Is it a big amount of time? No. It's what, a second, if that? And air just automatically goes down. Okay, it's going down its pressure gradients from an area of high to an area of low. This right here is, and for that fraction of a second before you go, everything's equal. Intrapulmonary and atmospheric pressure are equal. Okay, it is 760 millimeters of mercury. That is one that you should probably remember. Okay, so when atmospheric pressure equals the pressure inside the lungs, i.e., inside those alveoli, if they are equal, will air move?
No.
Heck no, right? Heck no. Excuse me. As soon as that volume increases, though, the pressure inside of here drops. Now, where in the world will air want to go? From that atmosphere rushing on in. Okay. So let me highlight some stuff here that you should remember. Excuse me, atmospheric pressure. What is it? It's the pressure of air in the environment, in the atmosphere. And it is 750 millimeters of mercury, or 760. I'm losing my mind. 760 millimeters of mercury. Okay. Obviously, that'll change depending upon where you live, but you get acclimated to that atmosphere that you live at, that altitude that you live at, and that becomes your norm. Okay. I can't remember what it is here. It's slightly different from that. Who cares? 760 millimeters of mercury is typically atmospheric pressure everywhere you go, unless you're at the top of the Himalayas. Intrapulmonary pressure is pressure inside the lungs, specifically the pressure in the alveoli. Why do I care that it's the alveoli? Because that's the only place where gas exchange occurs. Everything else, nothing. There is no gas exchange in the nose. There is no gas exchange in the trachea. There is no gas exchange in the primary bronchi, secondary bronchi, tertiary bronchi, bronchioles, maybe a tiny smidge in the respiratory bronchioles, but I don't give two bits about that. Where is primarily all gas exchange occurring for us in this class? In the alveoli.
Alveoli.
In the alveoli, you betcha. Okay. This changes. Atmospheric pressure does not change. It is amazing. Go across the border from Missouri into Kansas. Atmospheric pressure ain't changing. If I want to dip a toe into Missouri, atmospheric pressure don't change. Atmospheric pressure is generally constant where you live. The only thing that changed is that intrapulmonary pressure, okay? The pressure in the alveoli. That is what changes. That's what fluctuates as you breathe. So that's really the one major thing that's changing. Okay. We are going to see what happens when you start to breathe. All right. This is that brief moment in time after you. So it's that brief moment, final exhale, right before you inhale, everything's equal. If everything's equal, nothing can move. 760 in the atmosphere, 760 millimeters of mercury in the alveoli or in my lungs. Nothing moves. It's at equilibrium. So let's talk about normal breathing. Okay. We're only getting a change of 4 millimeters of mercury. That's it. It's just that as soon as I exhale for a fraction of a second, everything's equal. And then you continue the exhale and it's just 4 millimeters difference. You get that 4 millimeters of difference there between them, and air is going to come rushing in. We go from an area of high to an area of low. That's all. As soon as we get that 4 millimeters of mercury difference, air comes rushing in. Okay? Air comes rushing in. Okay? And you can see it can start at 1 and it maxes out at 4 millimeters of mercury. So my diaphragm and my external intercostal contract. That increases the volume of my thoracic cavity. Increases the volume, decreases the pressure by upwards of 4 millimeters of mercury. Okay. That is basic breathing right there. That is basic breathing mechanism. How does it stop? Well, that's where the nervous system comes into play. Okay. That's where the nervous system comes into play. Because exhalation is passive. All it is a relaxation of the diaphragm and of the external intercostal. And what does that do? It pushes up on the lungs. Diaphragm rebounds and pushes back up against the lungs, pushes it up. External intercostals relax. Ribs come back in. And just that tiny little bit of force that those two things do, those ribs and that diaphragm as it comes back up, helps us to increase the pressure, decrease the volume within the thoracic space, and increase the pressure. And that helps us to force air up and out. And that's it. That's it. That's it. So here, down here, looks at volume. And here looks at pressure. Okay. As we take that breath in, volume increases, pressure drops. Okay. Here's intrapleural, intrapulmonary. We just get a little drop. Two muscles, normal breathing. those two muscles, the diaphragm and the external intercostal, help to increase thoracic volume. As thoracic volume increases, the pressure drops anywhere between 1 to 4 millimeters of mercury. Air goes from high to low. Air from the atmosphere comes on in until they're equal. Rise slightly above and exhale. All of it based on Boyle's law. Eupnea is active in the breathing in, passive in the breathing out. So what stops those muscles from contracting?